Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Pavescape Design, a look into Festival Plaza, Adelaide. My name is Amanda, and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia recognises the traditional owners of the land, recognising their continuing connection to land, waters and community. We pay our respects to them and their cultures, and to elders past, present and emerging. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Urbanstone. Urbanstone is part of Brickworks Building Products, one of Australia's largest provider of innovative, quality building solutions. The beauty of Urbanstone lies in its creative design excellence by combining natural stone with a high-strength cement concrete mix. Urbanstone provides paving that's not only extremely durable, but also features the natural beauty of the real stone. Paving and accessories form a complete and integrated landscaping system. The resulting combination is aesthetically stunning and vastly superior in quality. So whether it's paving, bullnoses, bollards or other handcrafted accessories, it all comes together to provide an impressive look and feel that can transform projects into something truly extraordinary.
Throughout the past 110 years, the face of building materials has continued to evolve. We're here for a lifetime of living. This is Brickworks. More than brick, and more than just building products. We are a foundation for today's lifestyle and a leader for today's style. We manufacture a wide range of building products. Products like no other. Local and international innovation. Sourced from around the world to exceed customer expectations. Distinctive and luxurious products. Beautiful products that stand the test of time. Building inspiration and innovation with an unmatched standing of style. This is Brickworks.
Today we will hear from 3 speakers, followed by a live audience Q&A session, and I encourage you to send questions through to our speakers via the YouTube chat box throughout the presentations. I'd now like to welcome our first speaker, Paul Koehne. With over 15 years' expertise and experience in structural engineering, Paul has developed expertise in facade engineering and project leadership for a wide range of educational, defence, residential, health, commercial and sports projects. Paul has been involved in some of South Australia's largest projects, including the South Australian Health and Medical Research Institute, the River Torrens Riverbank Precinct Pedestrian Bridge, Osborne Naval Shipbuilding Precinct, and the Sky City Adelaide Casino. Paul has been involved on Festival Plaza as project lead since its inception in 2012, when Aurecon undertook the Riverbank Footbridge, then Sky City Adelaide, as well as working with ARM RSA with input into the original master plan. Paul will be joined by Sally Gee, a structural engineer at Aurecon for over 6 years. Sally has played a significant role in realising some projects, including the Adelaide Festival Centre redevelopment, on which she has been involved for the past 4 years, and Modbury Hospital. Sally has a strong interest in timber design and its potential for timber high-rise buildings. Please welcome Paul Koehne and Sally Gee.
Hello and welcome. My name is Paul Koehne and I'm the Aurecon Adelaide Building Structures Lead. Joining me today in a joint presentation is Sally Gee, who is one of our senior structural engineers. Ben Tolley from Hansen Yuncken is also presenting today following our presentation. Today we've been invited here by Engineers Australia to talk to you about the Adelaide Festival Plaza redevelopment. While Aurecon and HY have both been invited to talk today, we would like to acknowledge the wider project team. A project of this scale could not happen without a collaborative team. Firstly, I'd like to acknowledge the key clients and stakeholders, including DIT, DPC, AFC and Renewal SA. Secondly, I'd like to acknowledge the other consultants, including Mott MacDonald, Lucid, Bestech, Innovus, Sparkin Group, Hassel, Aspect Studios, ARM and Cox. The site has also had several contractors, including Hansen Yuncken, Lendlease, Walker, Chevello, Badge and Built. This list is not exhaustive, so I apologise for anyone I've missed. Thank you for attending. I hope you find it interesting, and once again, we welcome any questions you may have at the end of the presentation. So what are we going to cover today? The Aurecon presentation is split into two halves. The first being a project overview and the second half being more engineering related, where we'll go into some of the specific details and challenges on the project. I'll start with an overview of the wider Riverbank Precinct master planning, including some of the recently completed buildings, those under construction and future buildings. We'll then touch on the existing precinct conditions and talk about some of the complexities and intricacies of the precinct. After that, we'll touch on the architect's vision for the precinct. I would like to spend a bit of time looking at the precinct staging, including our innovative engineering-led design which enabled the vision of the precinct to be realised. The second half will focus on some specific engineering-related project challenges, including existing structural conditions, strengthening of old structures, working with limited existing structural drawings, dealing with the multitude of unknown and latent conditions, and finally, how we overcame these to assist with the delivery of the overall master plan. Adelaide's Riverbank Precinct lies immediately north of the Adelaide CBD. The location and character of this area is considered a critical element in the layout and makeup of the city of Adelaide. In particular, the Riverbank Precinct provides an important link between the city and its picturesque river environment. The precinct is made up of several key precincts, including the Innovation Precinct, the Entertainment Precinct, the Health Precinct, Cultural Precinct, Waterfront Precinct, and the Sports Precinct to the north, which is home to Adelaide Oval and Memorial Drive. In 2011, ARM released the Riverbank Master Plan, which focused on the revitalisation of Adelaide's core Riverbank precinct. If we zoom into the entertainment, recreation, sports and cultural precinct, there's been a buzz of construction for almost 14 years. Tower cranes fill the sky and construction vehicles spill onto the roads. Recently completed major projects include the Adelaide Oval redevelopment, the Adelaide Convention Centre Stage 1 and 2, Memorial Drive upgrade, Riverbank Precinct pedestrian footbridge, and most recently the Sky City Casino expansion. For me personally, my journey in the precinct started in 2008 with Samri, then straight onto the footbridge, and then to project leader for Sky City Casino and the Adelaide Festival Plaza redevelopment. The image on this slide is an old Google Maps image of the Riverbank Precinct area from 2014. The outline in pink shows the general extent of works, which forms a $180 million Festival Plaza upgrade scope of works. The Riverbank Precinct has had a stilted, almost confused past. It's home to some of Adelaide's most significant buildings, including the Adelaide Railway Station, Parliament House, and Adelaide Festival Centre. The existing plaza surrounding these buildings is considered old and dated, dilapidated, leaks like a sieve, and is mostly an unused, desolate area. The existing site is also home to several major loading docks, including Adelaide Convention Centre, Sky City Casino, commercial tenancies within the railway station, Intercontinental Hotel, Festival Plaza, and the Dunstan Playhouse. You can see them highlighted in the blue text. I haven't shown them all, but the red lines show some of the key traffic movements, and the blue lines show the key pedestrian movements. What's important to note is that the blue and red lines are intertwined, which is demonstrating the unfavourable, unsightly and unsafe constant interaction between road users and pedestrians. I touched on this on the previous slide. Since construction of the Adelaide Railway Station in its 1920s, Adelaide Festival Centre in the 70s and Acer in the 80s, this area has been constantly plagued with non-stop conflicts between road users and pedestrians. It's hard to create a pedestrian-friendly, thriving hub when a vast area of the plaza is covered with unsightly asphalt roads and loading docks. To give an example, the Riverbank footbridge opened in 2014 and is a major pedestrian connection between the Adelaide CBD and the northern banks of the Torrens River, home of the Adelaide Oval and Memorial Drive. Yet to access the city or the railway station, pedestrians have to walk straight through the Intercontinental Hotel loading dock. During major events at the Oval, when up to 60,000 patrons will walk across the bridge, Festival Drive is closed from road users. What this means is all loading docks and car parks are completely cut off and inaccessible for up to 5 hours at a time. This is clearly not a functional long-term solution. Similar issues were occurring throughout the precinct, including Sky City's casino main entrance, which is also used as a temporary and valet parking as well as a pedestrian thoroughfare. Similarly, again, the front door to the world-renowned Adelaide Festival Centre was accessed by crossing a road that was frequently trafficked by car and loading dock users. We can go on forever, but you can start to get an appreciation for the precinct issues and the engineering challenges that we had to overcome. So what was the vision? This image is courtesy of ARM as part of their early concept designs for Festival Plaza. I should caveat my summation of the vision with I'm an engineer, not an architect. The key vision is for a vibrant, thriving riverbank precinct, an area where people will not just pass, but will stop and congregate, a destination in itself. But people don't just stop for no reason. So the long-term vision included retail shops, shaded areas, seating places, interactive play areas and water features, and of course, direct access through to the picturesque Torrens River banks. It must also be capable of hosting major events such as concerts, fringe shows, and New Year's Eve parties. As part of the project, the main entrance for the Dunstan Playhouse and Adelaide Festival Centre are also being raised to the upper level, with all road users and loading docks travelling below the plaza. This vision also therefore provided separation between road users and the public. So let's get into detail. The following pages are the staging plans for the Adelaide Festival Plaza redevelopment that was submitted as part of the 2015 development approval application. The first stage shown above was twofold. Stage 1A is what was referred to as AFC Early Works or grade separation. As the name suggests, it relates to the first and most critical stage of separating vehicles from pedestrians. Stage 1B was focused on revamping the northern face of the Adelaide Festival Centre to provide the critical connectivity to the Torrens River, but most importantly, relocating entrances of the theatres to the northern promenade to enable construction on the southern side. I've intentionally referred to the first stage as unlocking the precinct, as completion of these works were paramount to enable all other works on site to commence. The loading docks were typically accessed from south and east entry points, both of which needed to be temporarily or permanently closed. But we also couldn't shut down loading docks for 5 years during construction and cripple the precinct and the businesses within it, particularly when many of the loading docks operate 24/7, 365 days a year. And the precinct included Adelaide's largest public transport hub, which transports tens of thousands of commuters daily. We needed a complex, innovative, and engineering-led solution that could convert access to the precinct and the loading docks to the west, while simultaneously maintaining uninterrupted access to the loading docks, enabling continuous pedestrian flow through the precinct, and creating grade separation between pedestrians and road users. The question that remained was this even possible? Even as I describe it right now, I can't describe the complexities associated with what was required here. I haven't even talked about the fact that that we also simultaneously constructed the major Sky City Casino expansion above this area, while it remained open to the public and the loading docks. The subsequent packages were developed in multiple stages. In addition to the Festival Plaza upgrade, you can also see the other ongoing developments subject to separate planning applications. The works were intentionally staged and coincided with completion of other developments in the area. For example, Stage 3 and 5 were completed prior to Stage 2 and 6. The reason for this being that Sky City was completed first, and Stages 3 and 5 were required to be completed to enable access to the new Sky City Casino building. Sally will discuss Stage 3 and 5 in later detail, as this includes strengthening of the 1920s Station Road and the 1970s Dunstan Playhouse. Stage 2A were then completed, followed by 2B, 6A, 6B, and 6C. Stage 2A represents the area above the existing 1970s Adelaide Festival Plaza, and where much of the presentation will focus today. It's worth also noting that all of these structures were heritage listed and subject to stringent restrictions on what we could and could not do. Stage 2A, Stage 2B and 6 represent new plaza that was constructed concurrently with and above the Walker structure. So how did we do Stage 1? The Intercontinental Hotel loading dock needed to stay in its current position, and so did the northern entry to the Adelaide Railway Station. So we came up with the idea of constructing a new basement adjacent to the railway station and within the hotel itself. The basement had to be partly constructed within the hotel for two reasons. Firstly, so that we did not impact the long-term operations of the Intercontinental Hotel, and secondly, so that we could maintain continuous thoroughfare for pedestrians exiting the railway station into the Riverbank Precinct. The idea was not originally supported, but there wasn't many options, and through clever engineering and carefully considered construction sequencing, we were able to demonstrate to DIT, the stakeholders and the builders that this was possible. There was also a very stringent dilapidation survey undertaken prior to commencement of works and strict ongoing survey monitoring to ensure that the existing heritage structures were not damaged during construction. We also had to negotiate with the Adelaide Convention Centre to allow the Intercontinental Hotel to temporarily share their loading dock for 12 months and create a pathway through the ICH loading plant room for safe, clean and hygienic transfer of the Intercontinental Hotel goods and services. At completion of Stage 1, we're able to permanently close all other vehicle entrances into the site and rely purely on access to the west for service vehicles needing to access the loading docks. The photos show here both the construction of the new basement and the finished product, including the new SkyCity Casino expansion and the northern entry into the Adelaide Railway Station. It's hard to imagine the transformation that has and is occurring in this precinct. Most people would be unaware of the fact that we've constructed new basements below the northern railway station entrance where vehicles freely travel below while pedestrians walk above. I'd now like to hand you over to Sally, who's going to focus on the structural engineering design of the Festival Plaza and the associated complexities with navigating historic structures.
Thanks, Paul. As Paul mentioned previously, the aspiration for the project was for a vibrant, thriving riverbank precinct, an area where people would not just pass through but stop and congregate, a destination in itself. And that was also capable of hosting major events such as concerts, fringe shows, and New Year's Eve parties. Aspiration, coupled with an existing nearly 50-year-old ageing structure, came with significant challenges, as you can imagine. In effect, we were trying to take this and make it into this. One of the first and ongoing challenges was the level of existing documentation that we had available to us. This was the original structural drawings for the project. We had access to those, however, they were scattered and scanned from microfilm, incomplete, and to varying degrees of ready. In addition to this, there had been several modifications to the structure over the years, which were not well documented. So we've combated this in several ways. Firstly, we got very good at deciphering little black blobs into marks, which could be 3/8-inch rear marks and similar. We also used our extensive knowledge of the site to understand where modifications had occurred from the original documentation. We used a series of historical reinforcement guides as well as engaged Adelaide University to undertake material testing on both the concrete and the reinforcement to validate our assumptions. And we did what all engineers do in these situations, which was we made appropriately conservative engineering judgments based on the information that we had to hand. This is just a snapshot to show the level of documentation that we were dealing with in many instances. You can see that the text is very unclear and it was quite hard to decipher what the reinforcement was in many locations. Unlike lots of projects of this nature, we did actually have an original loading diagram for the plaza, which stated a loading equivalent to 3.83 kPa. The drawing doesn't stipulate whether this is dead or live loading, but it's also much lower than a modern plaza would be designed for these days, which at a minimum would be 5 kPa and more likely 10 or more to allow for vehicles and event setup scenarios to occur. However, despite having the loading plan, we still needed to validate this and both to verify the loading against the structural drawings that we had and also determine whether we could justify a higher loading to be achieved, because even without the live load, there was still a significant superimposed dead load being proposed to account for the modern Pavescape design, including the paving build-up itself, which alone was 2 to 2.5 kPa, as well as extensive landscaping, seating, shading devices, lighting, and etc. Upon detailed analysis of the various structural elements making up the plaza, which I'll go into a bit more detail shortly, it became clear that in several areas we couldn't even justify the existing structure for the documented live loading, let alone higher, or the 100 to 200% increase in the SDL from the original plaza. To take a step back, I just want to walk through the sheer number of different structural types that we needed to analyse and determine the existing capacity for. Here you can see on screen I've highlighted just the extent of the existing structural elements that were being retained as part of the new plaza. We had an array of different structural types, including a long spanning two-way waffle slabs where we had two-way spanning beams of up to 15 to 18 metres long in each direction at approximately kind of 3 metre spacing with thin 100mm slabs in between. There was a section of long spanning steel composite slab with beams spanning approximately 24 metres. This slab was located over the Space Theatre in the Dunstan Playhouse and is a two-layered structure, as you can see in the snapshot, and allows for an acoustic isolation between the structure and the surrounding elements for that theatre space below. There were areas where there was thin 100mm to 130mm thick slabs over closely spaced, long-spanning, passively reinforced concrete beams up to 18 metres long. It's worth noting that for these areas, each beam was individually reinforced with bespoke bar curtailments and stirrup arrangements, meaning that each beam had to be assessed separately. There was no ability for bulk batch analysis or bulk processing here. Each beam had to be assessed on a case-by-case basis. There were areas where there were thin slabs over internal load-bearing blockwork walls, and these areas were perhaps one of the most modified spaces over time, with internal walls having been demolished and replaced with either walls in slightly different positions or load-bearing beams and columns, which we needed to verify on site. There were areas of infill precast slabs, of which there were 3 or 4 different types with various spanning arrangements to be considered. And then perhaps the most unique structure on the site is the umbrellas, which are standalone octagonal structures with a single precast column, radial tapering precast beams, all tied together with an in situ concrete slab. You can see a snapshot there and also an image here of one of the umbrella structures. They are, quite unique structures, and it's very impressive to understand that engineers back in the 60s and 70s designed these by scratch without computer analysis techniques that we have today. Once we'd established the baseline loading capacity for the various plaza elements, we went to work on how we might strengthen the plaza for the current design. The new plaza had a fundamental change in drainage design from a pervious top layer of precast biscuit pavers of 60 to 80 mil thick on concrete stools, allowing water to drain through the pavers, under which there were slabs either screeded or constructed to falls. And it was changing to a modern surface draining direct stick pavement system. This meant that the plaza had to accommodate a full paver bedding build-up, including screed for drainage to falls, paver depth, mortar and bedding, waterproofing, and whatever strengthening we needed to put in there. And due to the existing door thresholds, this all had to be achieved within the existing levels on the site. Hence, the key challenges here were accommodating the additional SDL, which was, as I've mentioned, 100 to 200% of the original paving system, as well as maintaining the existing threshold levels. As you can imagine, this precluded some types of strengthening, including bonded topping slabs in many locations due to the levels. There was also the added difficulty of the majority of the external areas being open foyer or performance spaces internally below, limiting options for new vertical structure beneath to help strengthen. All these factors led us to the current strengthening design that we have here, which is really bespoke to each of the structures we have beneath, but primarily comprises a combination of bonded topping slabs where the levels would allow, topping slabs on small upstand hobs, surface bonded carbon fibre strips to both the top surface and the soffits, and some steel strengthening beams, although these were kept to an absolute minimum. You can see the extent of strengthening that was undertaken in these following slides. So the one up on screen here is the plaza out the front of the Dunstan Playhouse, where we had the long-spanning waffle slabs and the long-spanning acoustically isolated composite slab. And then this is the AFC Plaza surface strengthening. You can see there's an array of different CFRP strips arranged around the site and to the soffit as well, which involved pulling down the ceilings within the AFC foyer. To add complexity, all of this was undertaken concurrently with us completing a full re-waterproof of the roof shells at the same time with full scaffolding decks to hold the roof and the perimeter of the Festival Theatre shell, and finishing scope from the internal foyer fit-outs to enable those new Plaza entries into the AFC and Dunstan Playhouse, which Paul mentioned previously, which was started back in early 2017 and had been on hold for several years. During that period, there was also a change in architecture team and other changes to the scope on site, and also in the midst of a global pandemic. So safe to say there were some challenges for the team along the way. But this is where we've ended up, with a plaza that's capable of taking much more loading than previously and supporting the modern Pavescape surface that you see there today. Despite the challenges that were involved in this project and others where we're involved in the precinct, we're incredibly proud of the role we played in modernising this area of Adelaide and revamping this very important and iconic state asset. Thank you.
Thank you, Paul and Sally. I'd now like to welcome our third speaker, Ben Tolley. With over 20 years' experience in the construction industry, Ben has successfully delivered some of Hansen Yuncken's most complex and technically challenging projects. Focusing on cultivating excellence in his teams, Ben develops a strong understanding of project stakeholders and their objectives. Most recently, Ben has led the project team in the successful delivery of the Adelaide Festival Plaza upgrade, which included slab strengthening, waterproofing, landscaping and infrastructure works in the heart of Adelaide's CBD. Please welcome Ben Tolley.
Thanks for that introduction there. My talk today is going to be about the Adelaide Festival Plaza project and Hansen Yuncken's involvement in that. So looking at this picture we have up here gives you a really good bird's eye view of the project and the landscaping around the Festival Theatre, the Dunstan Playhouse and the Sky City Casino. Just looking at what we're going to talk about today, I'll introduce myself and the project team, HY engagement, project overview and scope, have a look at part of the existing structure, provide some information around the execution of the project, mainly around carbon fibre and the paving, look at the major challenges that we had and how we dealt with those and the key takeaways. My name's Ben Tolley. I've been at Hansen Yuncken for around about 17 years now and been in the industry for 25 years. I've done all sorts of projects from hospitals to multi-storey buildings to the complex landscaping projects like this one. And I've have a vested interest in this project. I really enjoy the Festival Plaza, really enjoy the Festival Theatre and the surrounds. And so to me, it's been quite important to deliver a project that I can see and I can present to the public. Obviously, I can't do that by myself. So I'll introduce a very brief introduction with my project team and give some context around them. So on this project myself, of course, I have two contract administrators, Amelia Hunwick and Taewee Kim, a services engineer, HSE supervisor, an undergraduate, and a site manager, Brett Hughes. And you can see from the size of our team that we needed extensive experience for this project because there are 5 odd stakeholders here. There are many parties that have a vested interest outside those stakeholders. It's highly political, and most importantly, the Festival Theatre had to shut down to enable us to deliver these works, which is very unusual, especially after a COVID period for a theatre to be shut down. So we had a limited time frame to deliver this project, and there was no movement around those time frames. So when we approached this project, we really need to look at how we're going to meet those time frames. They were much shorter than you would expect. But we were quite confident that we could hit those milestones, and we have successfully done that through the Pavescape. To give some context around our engagement, it's important to understand that we had a lot of involvement in the design. So we're engaged as a managing contractor. Everyone's heard of that before. However, this one's slightly different than what some people may have seen. It has 2 phases. An ECI phase called an early contractor involvement phase, and the second phase is a GCS contract phase. So in the first phase, we have the ability to provide alternatives, look at the design, look at the program, finalise our program, and commit to costs and time with our client. We can then, at the end of that process, we agree the GCS, which is a guaranteed contract sum. Everything gets locked in stone and our contract is set, and then we go away. Through the ECI phase, we may have already started construction, but definitely through the GCS phase, we have committed ourselves and will continue with that guaranteed contract sum till it's complete. The advantages of that contract type is that we have the ability to work with consultants to develop different design, achieve the different outcomes, very collaborative, so we're all on the same team, we're open book, and we embed contingencies for some known unknowns. So we're able to manage some of those costs ourselves and make sure that we don't go over budget. Looking to the project overview and scope. So the location of the project, for those who are not familiar with Adelaide, it is near Adelaide Oval, near the Sky City Casino project, which is another key project for Hansen Yuncken, and next to the Dunstan Playhouse and the Adelaide Festival Theatre. There's two projects that are contained in this scope of work. There are two separate contracts. So project stage 2A is in the red, and 2B and 2C is in the blue. Both projects contain upgraded strengthening, modernised waterproofing and movement joints, screening to falls and paving, precast elements including balustrades and planters, soft landscaping, decking, lighting and security. To keep it simple, we're just going to talk about the area in blue. Very similar concepts, but this is a little bit more exciting from an engineering perspective because we're heavily involving carbon fibre strips. So let's look at the order of works. So the order of works is such. Demolition of existing screed. So on the top deck surrounding the theatre, there was existing paving and screeding that needed to be removed. And then when you see the picture, that was a fit out before we started, and that's actually the picture when we finished, but it looks very similar. We had to pull all the ceilings out inside there, remove some services, relocate services, and get it ready for the carbon fibre. Then we go on to the carbon fibre, we scabble and prepare the concrete surface, install the carbon fibre, screed to falls, waterproofing and jointing again, rebuilding the fit out after the waterproofing is done, and new carpets, and then we continue the paving and screeding, and soft landscaping and services. Now, working with the existing structure, this structure was built in the 1960s, and having a chat to people around the industry, everyone had a go at putting these slabs together, and it really wasn't the highest of quality as you expect, not like what today's standards are. So when we're going through the demolition, you can see that the structure was going to reveal itself. There were differing slab qualities throughout that needed repair. There were low reinforcement depths, again needed repair, and unknown beams. So if you look in the photograph on the left, you can see a beam that runs through the middle there. So we had to lay carbon fibre over the top of that, and you can't do that with a beam in that location. So I'll talk about that in the next slide. The existing services. So again, you can imagine 1960s building that has limited refurbishment throughout its time, and then we have to install carbon fibre to the soffit. You can see there's some services left over. We removed a lot of those services. We removed a lot of the ductwork and the fire services, put the carbon fibre up, then had to replace those services at a later date. Extending on from the paving area, we had a lot of precast elements. So you can imagine once you've done a lot of demolition, you cannot start your shop drawings or complete your shop drawings until you have all surveys done. Throughout that phase, which means the construction of our precast was quite late in the game because of those elements. And also we found that a lot of the fixing had to change throughout the areas just because there was low slab depths. Let's look at logistics and construction planning. Because of the short time frame that we have here, look like any other project, you need to maximise the amount of time that you've got. So we really had to work carefully to ensure that we can get out of the job as fast as possible and efficiently as possible. Again, it's a 1960 slab, so the slab weight was quite low, 500 kilograms per square metre. Some areas down to 100 kilograms per square metre. Very, very light. So what we do is we firstly look at where we're going to load our materials in, which is from the light green area in the top left. Then we look at how we're going to build out of the job. So looking at the red line from the bottom left, heading to the top, we start from the back end of the job and work ourselves out. Loading all those materials through that area is quite critical. You need to spread your loads out. Limit the movement of materials. You need to make sure they're out of the way of people. And then you need to make sure that your demolition materials can get out at the same time, all whilst looking at that very low limit on the slab. Loading paths, spreading out of materials, and the construction technique is quite important. Lastly, when you've got precast elements, you're working with existing structure. We had to change a lot of the precast elements to be smaller, so the size of the crane gets reduced and the size of the element gets reduced. So all those little things add up to a lot of time saving. Looking at the execution, now you can see from the yellow lines on the left, there's carbon fibre on the soffit and there's carbon fibre above on the top surface. So if you look at the right-hand photograph, you can see over there's a remnant of that beam that I showed you before. Now you can see we had to scabble the top of that, get it down to level, and then we had to epoxy. The epoxy layer to provide a nice flat surface because the carbon fibre can only bend so much. Once that's cured, you put another epoxy layer and then you start laying up your carbon fibre. You can see from the grid pattern here, the carbon fibre is extensive. The slab was in poor condition. You had to level the slab and then start that whole process. Carbon fibre and the epoxy, mainly the epoxy, takes 7 days to cure. We prove that it's been cured and we've got the adhesion by adhesion test. You can see that in the bottom photograph with a small piece of carbon fibre with a circle missing. So that's our pull test. From a construction perspective, we need to understand that we need to finish the carbon fibre on the top and underneath before we can go to the next stage, because we need to lift up the capacity of the slab to enable then loading of the extra materials we're going to put on top. So now we're starting to load up those materials. You can see here what you're doing is you're sand seeding the carbon fibre. That's the sandy looking material on the grid pattern, you see that? And then we're starting to screed. The screed and then the waterproof. The screed that we have on this job is a Veloci product, very lightweight, meets the density requirements, which are quite low on this project, and also, and most importantly for us from a construction perspective, is really fast drying. We've managed to reduce drying times from another product to this product from 7 days down to 3 days. For us, that 3 to 4 day saving is massive over a large area, so that adds up to over a month's worth of saving in time. On top of that, then we've used the polyarc product, a specified product that we used on the previous stage that I showed before, the 2A. We replicated that in this project, and that product, again, very fast drying. We can prime it and lay it within 24-hour period. Once that second layer is dry, we can work on that within an hour. A lot of products around, you need to leave it, let it cure for a couple of days before you can go back on. So you can see between those two products, you've got a really good chance of finishing this whole project. We have all those square metres to do, thousands of square metres to do, and only about 10 weeks to do it. So those sorts of small things, we spend a lot of time researching to enable that we can actually meet the program. So lastly, we look at the execution of the mortar bed and paving. In the yellow, you can see that's nominated. And then we look at the picture there. You can see we've had to jump over a joint. The paving on the right is completed. Then we move into the left, start the mortar bed, then put the pavers on top. Not a fast process, around about 20 square metres per day in that particular pattern. But most importantly for this is the quality of the products you're using. That's a quality screed that was put down, but more importantly is the quality of the stonework that's been put down. These are solid pavers, 50 mil thick. They need to be even width, even depth. If you have any variation in those, you will definitely spend time sorting materials out, and then you'll be bringing other materials in, and you're going to have loss of time, loss of hours with productivity of people, and it's going to slow the job down. Very, very important to have a high quality product. And you'll see if you have a chance to walk around, this is a high quality product, and it's gone down very quickly, and it has produced the quality results that people are after. Now we look at the major challenges and actions on the project. For us, procurement of materials, and this happened in particular due to the ECI phase when we're getting prices from the industry, and we're now starting to get some feedback from people that the materials aren't available or they're hard to get. So the industry is very busy at that point in time, and also we're looking at COVID times. So deliveries are slow, they're inconsistent. Now we're having shipping problems. So all these things have to be looked at. But two standout elements that we had were the carbon fibre and the waterproofing materials. Carbon fibre was through Seeker, and Hansen Yuncken, with a great buying power and good relationships with our contractors, were able to secure that carbon fibre, and were able to secure the materials that were on a boat coming over to Australia at that point in time. Had we not have done that and purchased those materials ourselves, we would not have met the time frame of the program. There are other materials that were around, but again, they were not available to us. They were coming in on a boat, and who knows where they were going. They could have been stuck in the Panama. We have no idea. Secondly is a waterproofing material. So we worked with our subcontractor to ensure that material is put to one side for this project, and we were able to keep that for ourselves. Should we had a delay, the material again was overseas. It's going to come by boat. You can't air freight it, it's highly volatile. And so those two things together have been really, really essential for us to meet our program. So back in the ECI phase, alternative materials to meet time frame, that was essential for us. Looking at those screeds, what was available from the industry. We looked at half a dozen screeds to pick one that needed to be lightweight and have low curing times. Drying times had to really be reduced to meet our program. That was another essential element. That, with the waterproofing and the ability to get onto the job really quickly, was really essential for us. Thirdly, we're looking at the poor existing structure and lake conditions, impact on program. There was no possibility of getting extension of time for these, and it really doesn't matter to us. That's not what we're looking for. We just want to meet the time frame. So relationships with engineers and with suppliers to be able to respond to those changes when you have those unknowns is really essential. Seeking epoxy layers when the material might be sitting in Sydney or the country has run out. Again, we can use our buying power, try and get that for ourselves and keep the project moving. Weather and its impacts, both hot and cold. Rain will delay your screed. Again, you have a long cure screed, then it gets wet, it takes you even longer again. So dry, short curing speeds for your screeds, plastic over the top, shed the water. All those little things are really essential. On the other end, if it's too hot, the material goes off too quickly, and then you get debonding. So you've got to be quite careful about getting that in between. This project was undertaken during the winter period, so you get all those sorts of things happening. And lastly, the logistics and site loading, working with the light slab and the capacities. Really have to get into that nitty-gritty of where you do have extra capacity. How do you move your people around? How do you get over the top of those things? Because they can really hold you back. You work to keep things too simple, you'll start losing time. You'll burn up man hours trying to move materials out by hand, and that will slow your job down. That's not what you want. So we've been successfully able to work with the right people on the project to be able to get those things to happen very quickly. Lastly, I'll look at the key takeaways and beyond those construction items. Product selection can significantly improve the outcome of a project by reducing the construction periods. Spend time looking at alternatives. The project team needs to be able to look at those. and review those and provide feedback quite quickly because it is a very fast-paced environment. Carefully review the existing structure, be available to provide rectification techniques. That's for the engineers out there. Be on hand. We need you down that afternoon, the next morning. Provide quick responses to us, keeps the project moving, especially when you look at a lot of these unknowns happening in existing buildings. We need detailed slab capacity documentation beyond a one-figure load rating for a slab. Quite often you look within that, and there was areas in this where we had mushroom columns underneath, so the slab capacity increased in some areas. So then we can look at different machinery for those areas, even though it's only isolated. If you have that information on hand, for us, we can digest that and we can really use that to start speeding up the job and make it cheaper for our clients. Be nimble in answering questions and reviewing alternatives. Again, fast response maintains productivity. Engage a leading head contractor like us who is willing to challenge the design and engage and use their best subcontractors to achieve the best and quality outcomes. Someone who partners with the right people has a really good chance of producing the right product for people. Employ a contract that enables design input and the team that works towards the best results. And lastly, high quality products and consistent products can vastly improve the completed works and quality for our clients. Thanks for listening.
Thank you, Ben, and a huge thank you to Paul, Sally and Ben for this afternoon's presentations on what is a very exciting project in Adelaide CBD. So it's now your turn to get involved. Our speakers will now come together to take your questions. Thank you to everybody who sent questions through on registration. And if you'd like to send through a question now, if you could do so via the YouTube chat box. Please, if you could, say who your question is directed to as well. We might keep you on the podium, Ben, for a minute or so. We've had a question that's come in from Grania in New South Wales asking, what consideration has been given to ongoing cleaning of the paving, given current slip rating requirements, making pavers so difficult to clean? Thanks, Ben.
Yeah, thanks for the question. Whilst we weren't responsible for the selection, the product is a consistent product across Adelaide. It's a high quality stone product. It's like a granite. It actually requires very simple cleaning from day to day, which is just a machine and water scrubbing machine. That's all you need. The pavers are not sealed, so I can prove how robust these products are because we had to build on them. We had forklifts, we had trucks, we had all sorts of things running over these pavers, and they've maintained their slip rating, and they've stayed in very, very good condition. So, like I said in the presentation, you pick a very high quality product, it will last and have minimum maintenance in the future. Thanks.
Thanks, Ben. We've got a question that's come in for you, Paul, and it's come in from Yan Wai in New South Wales, talking about the role of wind, asking, how does wind play its role in the redevelopment of the Plaza? Paul?
Yeah, good question. I think, and there's probably another question that talked about wind on specifying with suppliers' products. So I think just to answer twofold, wind is designed just standard to Australian standards. We didn't specifically do a wind pedestrian analysis as part of the Festival Plaza itself. However, the buildings around it, so for example, SkyCity Casino, Walker Development, Festival Plaza, as part of development applications, we need to do a wind study analysis to understand whether, adding a large volume of facade, whether that dumps wind down at the plaza level, which then impacts the ability of pedestrians to circulate around the plaza. So I guess to answer the question, it's more around large buildings and the ability and the risk associated with moving wind to areas where pedestrians, or then becomes an adverse issue for pedestrians.
Thanks, Paul. We've had a question come in from Reese, who is in Queensland. Good afternoon to you. Asking you, Paul, how did you deal with surface drainage and runoff? Any thoughts on permeable paving? Thanks, Paul.
Yeah, good question. So Sally did touch on that in the presentation. The original design was I guess it was precast on I guess little stilts, I guess, and then we had falls underneath the pavers onto the actual concrete itself. The issue with this was a couple of issues. Number one was the type of paver, so we couldn't actually get a warranty on the paver that we wanted to if we used stool options. Other issue with that was the actual geometry of the panelization, I guess, of the pavers. They weren't square and they weren't rectangular, and they were different shapes. So we also we couldn't find a proprietary product that would actually warranty the point loads and the live loads that would happen if we went to a raised system. And I guess the last issue with that again was also the waterproofing and things like that. We wanted to actually have I guess a bit of a trial and a proven type of waterproofing system. So we had obviously the best solution is you run off naturally off the top of the surface, but then we had waterproofing in multiple layers below the paving itself. So yeah, I guess it was the pattern of the paving itself, the type of waterproofing, and then the paver itself also didn't allow for that.
Thanks, Paul. Sally, do you want to add to that at all?
No, just to say that, yeah, I think Paul's covered the pertinent aspects of that. And to be clear, Aurecon didn't undertake the civil drainage design ourselves. That was undertaken by Moore McDonald.
Thanks, Sally, for clarifying that. We've had a question that's come in from Michael, asking you, Sally, are the umbrella structures designed for earthquakes?
Yeah, it's a really great question. I think the original structure was designed in the 1970s, or the final documentation for the AFC was in the 1970s, and then Dunstan Playhouse a couple of years later. So that actually predates the first earthquake code in Australia. So they probably wouldn't have been designed to what we would consider, modern earthquake loading. However, our assessment of it was that there were several parts of the plaza that were tied together to help restrain the tops of those umbrella structures, and also they're on quite a large pile cap for which we had pile capacities noted on the existing drawings as well. So there was a bit of, I guess, dual action there in being able to take some overturning as well as being tied into parts of the plaza.
Thanks, Sally. And we've had a pretty big question coming from Gabriel. Good afternoon, Gabriel. Gabriel, who's in the ACT, asking Paul, what are the key lessons learnt and what would you do differently if you are to start this project from scrap again? Heaven forbid.
Yeah, it's probably a challenge to answer that, and everyone's going to answer that question differently. I guess from my lessons learned in projects and how they're actually funded. I mean, one aspect would probably be maybe spending more time with consultants pre-budget and pre-financing of the project, so they can understand more of the risks, and then they can, I guess, make sure they've got an appropriate budget, because it was a bit of a challenge. Again, I think this was a bit of a unique one in that because we were dealing with such an old existing structure, there's a lot of unknown conditions. So again, I would get the engineers involved much earlier in this case. Like a lesson learned was, for example, like Ben touched on, was removing and replacing the ceilings in the Adelaide Festival Centre. The ceilings were actually only constructed 2 years before we had to replace them. So probably just getting in early with understanding what the risks are, so that we can both allocate cost to a budget's program. And the other one, to be honest, is whether or not you would actually be cheaper to just demolish part of the structures themselves. That was obviously a challenge because a lot of it was heritage listed. Like as an example, even the soffits, so the underside of the umbrella columns themselves, they were also heritage listed. So we couldn't put FRP or steel beams or strengthening on the underside of those. I think that was probably it, but I'm not sure if Ben or Sally want to touch on anything, because this is quite an open-ended question.
Yeah, I'll jump in on that. Yeah, thanks. As I noted, it was stage 2A and then 2B and 2C, and so those projects were separate. But before we went on to 2B, in that consulting phase, we worked with Mike McDonald, who led the process, and brought all the consultants together. So we did lesson learned workshops. So we looked at what we did on the 2A and provided some improvements and rolled those back into 2B and 2C. So for those screeding and waterproofing layers, those things are rolled through, and that's where we had we used up our time efficiently to make sure we had better products on the next phase. So from that perspective, as a builder, we were able to save a lot of time.
Thanks, Ben. Thank you. We've had a great question coming from Dennis, directed to you, Paul. It's another big question, and maybe answer this from an engineering perspective. That Dennis is asking: how are business owners impacted by the works consulted during the design construction process, which I think you've just touched on in your last answer? But do you want to expand on that a little?
Yeah, it's a good question, and I should just expand on what Ben said. So obviously DIT, so Department of Infrastructure and Transport, were our client, and Mott MacDonald were the project managers. So Mott MacDonald, as part of the PM role, they did a lot of the stakeholder. We were obviously involved in it. So there was probably a couple of things. So Sky City Casino, as an example, they were a major stakeholder. They lease 78% of the Adelaide Railway Station. But in this case, they were also building expansion. So they were quite easy to work with in terms of it was in their beneficial interest to liaise with us and understand what the conflicts were. Intercontinental Hotel was the same. So while we're interrupting their business, we were also building them an entirely brand new loading dock and a much more expanded services. So we worked really collaboratively together because I guess we kind of worked towards mutually beneficial outcomes. So I think it was probably an unusual project where, like, even myself personally knew the manager of Intercontinental Hotel, which is not unusual. It's quite unusual for a structural engineer to do that. So it was managed actually quite well, and everybody was quite understanding and collaborative. Obviously, the Adelaide Festival Centre were probably the most impacted because they had multiple closing shutdown periods. In some respects, if there's no benefit of COVID, but in this case, we did, when that was closed down for COVID-related health pandemic reasons, we were also able to work with Motts and HY and the other builders to coordinate our construction work so that was a minimum impact on the actual owners and the businesses around. So I think, just working together collaboratively, and like I said, we all had the same vision and we all had the same beneficial outcome. So we worked quite well together as a team.
Thanks, Paul. Over to you, Sally. We've had a question that's come in from William asking, were there any geotechnical investigations to confirm the existing ground conditions? Sally.
Thanks, William. We didn't do any specific geotechnical investigations for the strengthening works, but as part of other works that we had done in the precinct, we had access to geotechnical reports from the northern side of the site, from when we did the Northern Promenade works, as well as kind of the southwestern of the site from the early works and Sky City upgrades around there. And we also had access through one of our colleagues, Dr. Peter Mitchell, to some of the kind of original geotechnical information for the site when the Festival Centre was first built. And as well as that, there were pile capacities and noted on some of the drawings for the piles. The structure was predominantly on piles or slab on ground. So we had access to a lot of that information to inform the design.
Thanks, Sally. And Ben, we've had a question come in from Amanat, who is asking, talking about risk and opportunities, asking, what is the risks and opportunities amount? How was this tracked throughout the duration of the project? And did this project have gain share mechanism? Thanks, Ben.
Thanks. Whilst I'm not at liberty to share the exact amount, probably go through the process is more useful for the people. So when we're going through that ECI phase I described earlier on, we go through and analyse all the risks on the project, and would allocate a budget against each of those. And each of those items would be reviewed by the cost consultant. In this case, it was Ryder Levitt Bucknell, and with Mott MacDonald being the project managers. And we'd agree a sum, and then that'd be embedded in a guaranteed contract sum. So that would help how it would be tracked, and then that we would apply a small percentage for unknowns, complete unknowns, where the others are known unknowns. And so we used our experience throughout that area to allocate that on each of those projects. The last part of that question was on basic savings share, which is implemented on this project. So yes, there is a scheme in place. So there's some checks and balances obviously on the way through. It's how a builder applies the monies on the project. For us, you do what you need to do, get the job done correctly, and at the end of the day, if there happens to be a saving, well, that's all well and good.
Thanks, Ben. Thank you. And we have a question that's come in from Ivor. And Ben, you talked about carbon fibre in your presentation, and Ivor's asking, what is the lifespan of the carbon fibre reinforced polymer?
So the carbon fibre itself has a 20-year warranty. More of the limiting factor is actually the epoxy layer on there, which has a much shorter warranty of about 7 years. So that's what's provided to us. It's a good product. I think when it comes down to it, you've got to make sure that you install it absolutely perfectly to maximise the longevity out of the material.
Thanks, Ben. Thank you for that. Good afternoon to Armin, who's sent in a question for Paul, following up on the question about wind. Paul, is it possible for uplift to happen for the Plaza? This happens on pavers used in balconies, etc. Thanks, Paul.
Yes, in raised pavers. In this case, like we said, everything's direct stuck, which is both the preference for water drainage as well as providing a warranty on the paver, as well as the point load capacity on the plaza itself. So the answer is yes, but in this case, we didn't need to consider it because everything was direct stuck to the actual base slab itself.
Thank you, Paul. And then we've had a question about the pavers and mortar that's coming from Theo, asking you, what were the actual pavers and mortar bedding specified?
Thanks. The pavers were a stone paver. They were supplied by the state, which is an Evanstone product. So they're a granite style product, very hard. Underneath that, we had a Mape stone mortar bed layer. Underneath that was the Polyac waterproofing system. Most importantly, underneath that again, which is where the weight issue came in, was a Velocit product.
Thanks, Ben, for that. And I do have a final question to all of you. Your presentations talked about this project. It's quite complex. It's very extensive. The infrastructure before it was ageing. And we talked about the risk, the opportunities. We've talked about the need for communications and key stakeholders that maybe are not normally in the mix. And on behalf of Engineers Australia and for you, Paul and Sally, as structural engineers, and Ben, I'd just like to get your view as well as a constructor. What advice have you got to our young structural engineers who are either considering a career in structural engineering or just coming through out of uni and are working as graduates? Starting with you, Sally, what advice would you give to young structural engineers coming into the profession?
It's a really good question, Amanda, and particularly pertinent on this project for me. I think I started on the project in about middle of 2016, so it's been 5 or 6 years on the project for me, and I was a fairly junior engineer when I started, and it's been a pretty challenging project throughout the journey. So, but when it comes to the end of it, I'm incredibly proud of having been involved in the project, and every time I walk past the festival centre or go to a show there, I can say that it's my project. So I think my message would be just, engineering and consulting can be a really challenging profession, but it's also really rewarding, and particularly when you get to have an influence on your urban built environment and be able to present those projects that, improve our public infrastructure, whether it be public spaces like the Festival Plaza or, hospitals, schools, or whatever it might be. I think it's really rewarding and worth working through some of those challenges, and the learnings that you get from those difficult periods is really important for your career.
Thanks, Sally, and well done. And to all our female engineers out there in the week that is International Women's Day week, a big congratulations. We're still only at 13% female participation, so hang on in there, because as Sally says, the rewards are amazing, and you have a chance to really shape our community and our society going forward. So, Paul, what's your advice to our upcoming engineers?
Well, I just sent Sally a note saying well done in my side chat. It's hard to beat that, actually. Sally, that's a really good summation. I think, to be totally honest, is it's a really rewarding career personally. I love being able to walk around Adelaide and show my kids. I've got 2 kids. I love being able to walk around them and show them what I've done, and even some of the projects that I've done, I still take a photo when I walk past them, and some of them opened more than 10 years ago, 15 years ago. So I think it's the rewarding, and there's a project like this. I mean, there would probably be 50 people in Aurecon that would have put time to this project. There would have been thousands of people in Adelaide that spent time on this job. So I think even just the team collaboration and the relationships that you build, like Ben and I, Sally and myself, Luke, who's the project manager from MOTS, like we build relationships that are long-term and meaningful off the back of this. So it's not just one project, but it's just the whole environment and the team and things like that you get. And you can't get a better feeling than that, than the recognition and reward and good feelings that you get. So yeah, I guess I would encourage people, and it does get hard. Like Sally said, there's times when, there's tears by me, there's tears by Sally. I'm sure Ben was pulling out his hair if we didn't respond to an RFI quick enough, but it's all worth it in the end. And I think if you stick through it and stay together as a team, and we've always got support around you. There's someone that sits above me, there's someone that sits above Sally. That you can stick through it, and at the other end, I guess it's a very good feeling.
Thanks, Paul. Beautifully said. And Ben, just to finish up, we've touched on the importance of communication, the importance of relationships with key stakeholders as a constructor. What advice do you have for our young engineers?
Yeah, it's a good question. I don't often get the chance to provide a comment around this. I would say, as soon as you can, get yourself in a position of getting out on site. If you get under the wing of a good engineers like Paul and Sally, really take the time to listen to people who've gone through the experience. And when you are on site, take time to talk to the constructors team, the site managers, the engineers, because they can really come from a completely different angle. We'll throw things at you and some things are silly ideas, but sometimes from silly ideas you come up with great results. And I've found the more that you work with your engineers and build on that relationship, you really do come up some really good results and really fast results. And quite often they're cheaper for our clients at the end of the day, and we're here to work for our clients and make them happy. So again, get out on site so you can, talk to anyone you can, talk to the person with the basic skills. You'll find that you'll learn a lot and learn really quickly if you talk to the right people.
Thanks for that, everyone. And yes, it's all about getting out there and talking to people. And I think lifelong learning springs to mind. That's all the time we have for today. So please join me once again in thanking Paul Koehne, Sally Gee and Ben Tolley for their time and insights shared at today's session. I'd also like to thank Engineers Australia's industry partner, Urbanstone, as well. As always, we're looking for your feedback, what's working, what can we do better. So to help us improve future sessions, could you please take a minute just to complete a short feedback form, which is linked in the description box below. Thank you again for joining us at this afternoon's Thought Leaders series, and we hope to see you at our next event. Thank you and good afternoon.